This video will show you the first tutorial for Bakery Relight 2. It will give you an overview of how the entire application works, so we recommend that you start with it before going any further. So first time you open Relight, you will see this base layout made of several windows that you can resize or replace by other windows in a list. You can split each window in two, and so on until you can create your own favorite layout that will be loaded automatically each time you open the application. If you want, you can use the menu window and open Save Layout in order to save these layouts as files, and you can use one of the layout presets. So for this tutorial, we're going to use the lighting layout. Okay, so now let's open the scene using the menu File, Examples, Baker. So here in the hierarchy view, at the left, we can see the list of nodes in the scene, and each time we select one of these nodes, we can see the attribute editor at the right being refreshed. We can see the shading tree being updated, but until here, we don't see any geometry yet. This is because the 3D view here is disabled by default. We actually don't want the geometry to be loaded each time we open the application. So to enable the 3D view, you have to click this first button here, and now we can see the geometry. So to navigate in the 3D view, you need to press the Alt key and then left mouse button to rotate, right mouse button to zoom, and middle mouse button to pan. If you want to view the scene from the point of view of a camera, you have to go in menu View, Camera, and choose the camera. There is only one. If you move the timeline at the bottom of the application, you can see that this camera here is animated to have a turntable. And the other way to do it is to select a light or a camera and then press space in order to see the scene from the point of view of this object. Then if you press escape, you are back in free view. So these geometries that you see here are actually Alembic nodes that have been exported from Maya using Bakery's plugin. You will find in the documentation some tutorials about it. But apart from these geometries, you will find a bunch of other nodes that have been created directly in Relight for the purpose of shading and lighting, like lights or shading operators and so on. So okay, now let's render the scene. So we are going in the render view, and we can either use the menu render here or press the shortcut R, or we can press the refresh button here. So first time we have a render, we have this small window here reminding us the render settings. So if we press OK, we have our rendering done. So now I have this 2D image that I can manipulate using the Alt key, and I can zoom and so on. But this is actually more than just an image, because I can select any object in my scene by picking in this final image. So here I am selecting the geometry nodes, which are called tessellators in Relight. But if I want, I can change the picking mode here using this menu, or by right-clicking in the render view to select the materials or the lights or displacement or whatever node I want to select. So I have access to my entire scene by just picking in my final image. So as I don't want for this tutorial to refresh my rendering manually each time I do a change, I'm going to use the menu Render Automatic Refresh. So now the rendering is going to be refreshed automatically each time I do a change if it is necessary. Now let's check what happens in the shading tree. If I pick, for example, the bakery logo, I selected this geometry node, and I can see the shading tree being updated, and this menu is telling me that I am seeing the material graph, so it means that I am seeing everything connected to the materials. This is because in Relight you can connect anything to anything, so you can have several nodes connected to your lights or to your procedural geometries. You can have compositing tree. So there are several ways of using the shading tree. So here the material graph is showing me these 4 nodes. The first one at the right is the tessellator, so the input geometry node that is loading an Alembic file. And as it is referencing an external file, I can double click on it and it's going to open a viewer dedicated for it. So I'm seeing the geometry here. The second node is the material, so it's the base material that we have in Relight, and it's, as in other softwares, we have diffuse, specular, reflection, and so on. And you have these 2 shading operators that are called shade ups in Relight. And these 2 shade ups are here referencing 2 input textures, one for the diffuse and another one for the bump. Again, I can double click on them so that I can see the image in an image viewer. So, well, this is useful to understand what these nodes are doing, but there is actually a much more interesting feature in Relight. You can select each of these nodes and use the menu Shading, View Selected Shader, or you can use the shortcut H, and then you see the contribution of this node in your final rendering. So this is the contribution of the material, but I can also select the texture, for example, and press H, and I can see how this texture is projected on my object and how it contributes to the final rendering. I can do the same on the bump, and now I can see this texture, how it is applied. I can even select the geometry node and press H, and I can see the mask of this object. And you can do this for several other nodes like lights and so on. So this is very useful when you have complex shading trees or scenes that you don't know, because you can easily understand what each node is doing. Now, you will surely be looking for some documentation on specific attributes or objects. Then you can see that when an attribute is highlighted in the attribute editor, a small explanation will appear at the bottom left of the application. If you want more documentation, you can right-click on a node from any viewer and then use the menu Documentation. This is going to open Relight's documentation at the corresponding section for this node. Okay, now let's see how to interact with the attribute editor. So when you select a cell, of course you can simply type a value. For example, here I can type 0.5, but you can also use mathematical operations. So I can do multiply 2, and this is going to multiply my previous value by 2. This is quite useful. You can even use it for when you select several attributes at a time. You can right-click and use the slider and slide from left to right. So here I'm changing my specular glossiness. When you have list attributes, you can right-click to see all the items in the list and change the value. You can copy-paste value from one attribute to another. So I can select the attribute, do Ctrl-C, and then Ctrl-V to paste the value. For color attributes, I can simply type the value. For example, 1, 0, 1 is going to show me a pink specular. But you can also right-click and see the color chooser here. So I can choose a color, press OK, or you can do it and check the Live Edit button. So now the color will change as I am moving my cursor in my color chooser. To finish, you can select one or several attributes and press the Delete key, and this is going to reset the attributes to their default values. So now I'm back to my original shading. Here you can see this arrow icon. That actually means that a shade up is connected to my attribute. So if I double click on it, it's going to jump to the connected node. And by the way, you can navigate over the last selected nodes by using these green arrows here, or you can even go to a specific node that you selected previously. So when you are tweaking a node, you can either press H to see only its contribution and then tweak it. So here I'm changing the hue value, so I only see the result for this node, or you can press R and do the same, but then see the result on the final rendering. You can use both ways. So let's start really editing the scene now. I'm going to pick the character's head, and I'm going to inspect the shading tree by pressing H on each node. So I can see that this is actually the entire character's skin. And again, I have two textures, one for diffuse and another one for the bump. But let's imagine now that I want to add more detail on the bump because this seems too flat. So I want to create a procedural noise that I'm going to mix with the input texture. So to create a shade up, I can either use the main menu Create Shade Up, or I can directly right-click in the shading tree. And here the shade up I want to create is a whirly noise. So now I just created this node. It's not connected in my shading tree, so it has no effect yet on my final rendering. But however, I can select it and press H, and this is going to apply it to my entire scene, so it shows me what effect it will have when I will connect it in my shading tree. So I'm adjusting the frequency. Let's say the value of 70 is good for me. And now, well, I have to create a shade up blend. And I'm going to connect the input texture into base color and the noise into color 1. Now the blending mode that I want is add, and now I'm going to connect it into the bump. And okay, well, I can see that here the noise is much too big. If you want to compare before and after your last change, you can use the menu toggle here. or press the shortcut T, so you can compare before and after. So, well, this is much too big, so I'm going to decrease the weight of my blend. So I'm going to decrease it to 0.1, still too big, divide 2, still too big, divided by 2. Okay, this seems good, but I actually want to increase the overall bump of my material. So I'm going to select the material, and if I don't know where to find the bump attribute, well, I can still use the filter. So I'm going to type bump in the filter. So here it is. So it's minus 0.5, so I'm going to put minus 0.7, and now I'm happy with it. Okay, so now let's do the same, but now I want to create a specular map. So I'm going to right click, and now the shade up I want to create is a pearly noise. So again, I can press H and see its effect on the entire scene. Let's adjust the frequency to 5. And now if I connect it to specular 1 color, because you can have several specular in this material. So, okay, it's fine, but now the overall specular amplitude has decreased. So let's put an amplitude of 2 in the pearly noise. And now I'm happy with it. So now let's store this image by using here the photo icon. And so that later I will be able to compare it at different steps of my tutorial. So until here I have done several tweaks in the scene, and you have noticed that each time the refresh was instantaneous, whatever attribute I was changing. This happens thanks to a unique feature in Relight, which is the caching, that can be enabled or disabled with this button or in the caching menu. So when caching is enabled, each time you render, actually a lot of 3D information is baked, and then when you do some changes in your scene and re-render again, the software automatically knows what part of the calculation really needs to be recomputed. And you can see that in practice, it's only a very small part of the whole calculation that has to be redone between 2 rendering. That's why it's so fast. And of course, what you are seeing is your real final result. It's not an approximation of your rendering. So now that we've done some shading, let's work on the lighting too. So we have this window here, the light set editor, which is showing us the list of lights in the scene, telling whether they are enabled or not, and eventually it's giving some information about light linking, which we don't have in this scene. So you can quickly add or remove lights by selecting the enable cells and pressing space to toggle the value, or you can right click and set it to on or off. And again, you can select one of these lights and press H in order to see the contribution of this light only in your final rendering, which is quite useful. Something else that you can do is to change the picking mode in the render view. So for example, if I right click and choose main light picking, now when I pick on my image, it's going to select the light that has the most influence in this point. So it's easy to find, for example, which light is causing a highlight or something like that. Something else that you can do is to right click and choose the all lights picking, and now when I pick, it's showing me the contribution of each light in the final color of this pixel. So now let's come back to tessellator picking, and if I select one of my geometries and I set my shading tree to lighting graph, now I can see all the lights that are illuminating this geometry. So I can see my 3 lights here, and eventually if there are some nodes connected to the lights, I will see them here, which is not the case in this scene. So for example, you could connect an input texture into your light to have a gobo light, or you can connect an ambient occlusion to your light in order to darken the illumination of these lights, or noise, or anything that you want. But here we just have the 3 lights. So let's start moving, for example, the key light. So I'm selecting the key, I'm going to the 3D view and pressing space. So I'm seeing the scene from the point of view of the key light. And now if I start moving it, well, I can see the rendering being refreshed. If you use the transform tool here, you will have all the manipulators. So you can control the starting point of the fall off, you can change the cone angle, you can move the target. If you want to snap, you can right click in the 3D view and choose aim at current point. Now you can rotate around this point. And okay, let's illuminate the scene from the top like this. Let's decrease now the intensity to 0.8, and I'm going to change the color so that it's a little bit warm. Okay, so now I want to play with the shadows. So my 3 lights here are using shadow maps. If I double click on them, I can see the shadow map viewer. And I want to add some blur. So first I'm going to choose a region. So I'm going to right click in the render view and choose region selection. If I frame like this, now if I re-render, for example, if I press H, it's only going to re-render in this region. So with standard shadow maps, the only control that you have for blur is this attribute, blur radius here, that applies the 2D blur in the shadow map. So here it's set at 0.3, so for small values it's okay, but if you increase it a lot, then you can see that the result is no longer realistic. Actually, we are losing the context. So if we want soft shadows, we need to change the algorithm. So I'm right-clicking on attribute algorithm, and I'm setting it to ray trace. So now the shadows are ray traced. There is no more shadow map here. And I have a new attribute, light radius, which allows to simulate an area light and have soft shadows. So I'm changing the radius of the lights, and okay, let's put a value of 20, for example, and I can see that the shadows remain sharp at the context and then get blurrier with distance, which is what we expect with soft shadows. So now I need to increase the sampling because I'm seeing some grain. So for example, let's put 36. Okay, so now it's fine. However, I can still do this by using shadow maps. I can right-click on algorithm and choose another mode, which is the soft shadow maps. So here I can see that I have almost the same result. I can toggle before and after to compare. But these soft shadows are obtained using shadow maps. Okay, so I want to use this mode for my 3 lights. So I'm going to select the 3 lights. And this brown attribute editor here is showing me a multiple selection so that I can edit several objects at a time. The grade values here mean that the values are different between the 3 objects. So I'm right-clicking on algorithm and I'm setting soft shadow maps. So now all my 3 lights are using soft shadow maps. I don't see any difference because I didn't change the light radius for the other ones. So let's select, for example, my rim light. Let's put a value of 5. Okay, let's increase the sampling at 36. Nice. So now I'm selecting the fill light. Let's increase it to 10, 20. Okay, 20 is okay. So, okay, now I changed the blur of my shadows, and if I render again, I can see this final rendering. So I'm going to take another snapshot, and I can compare before and after my changes. So what is missing now in this lighting is some indirect illumination because some regions are much too dark. So the easiest way of doing it in Relight is to use the render options here. I'm going to search the indirect illumination tab. Okay, let's set the environment color and put a bluish color for the sky. And now let's set the lighting mode to ambient first. So here I just have a flat bluish ambience, which is not very realistic because I don't have any occlusion. Let's store the image, however. And now I'm going to change the lighting mode to environment lighting. So now it's better. I have some occlusion. Actually, environment lighting simply illuminates the scene using this environment color with the occlusion. So here I have this blue sky dome illuminating my scene, and instead of a blue color, if you use one of your HDR maps and put it in environment map, you will have image-based lighting illuminating your scene. And now if you pick in the render view, you can see a new node appearing called indirect that is actually representing the indirect illumination from our render options. Because in Relight, any illumination effect like reflections, refractions, global illumination, everything can be considered as light, and you can do some light linking on it for advanced lighting setups. So here if you select this node and press H, you can see the contribution of this indirect illumination in the rendering. So here we have some grain, which is normal because the algorithm we use for environment lighting is ray tracing by default. And well, we would have to increase the sampling to improve this grain, but we're going to do something else. We are changing the algorithm to point clouds. So here some point clouds have been quickly generated, and I can see the results. So now I no longer have grain, but I have these artifacts at the context, which are even worse than the grain. So to understand what's happening, I need to inspect the point cloud. I can do that by double-clicking on the indirect node or somewhere in the render options page. And I can see the point clouds that are used to represent my scene. And here I can see that this representation is not good enough because I'm losing too much detail. I don't even recognize the character. So I need to decrease the size of the disks, and to control that I have this attribute disk radius here, which is the most important parameter that you have to tweak when you use point clouds. So you express this size in world units. So to understand the scale of my scene, something I can do is to right click in the render view and choose the ruler measures. So now by dragging the mouse I can see the distance between any point in the scene. So by doing that I can see that a value of 0.1 would be good, so let's put 0.1. And now I have a much better result. The artifacts are gone, so I can toggle with T to see the difference. And I still don't have any grain. Now if I double click, I can see that the point clouds now are giving me a much better representation of my geometry. So point clouds are a good technique because they give smooth results without any grain that don't flick in animation. So it's very interesting to use them. So I'm going to store this image, and now I want to add some color bleeding. So I'm going to change the algorithm to the lighting mode to global illumination. So now I can see quickly that the points have been shaded. And now I have my global illumination result, which is better than before. If I press H in the indirect node, I can see the contribution of the global illumination, so I can see the color bleeding. And if I double click now in the indirect node, I can see that now the point clouds have stored color too, and this color is used for the color bleeding. So let's store this image. Let's compare with the different results we've had. And actually point clouds can be used for very different effects like area light or glossy reflections. So let's try this. I'm going to add some glossy reflection in the ground. So let's pick the ground material. Let's decrease the diffuse intensity to 0.4. And here you can see that the point clouds have been automatically reshaded to update the ground color, which is good because you are sure that you always have the correct values in the point cloud. But if you want to trigger the point cloud reshading manually, you can go in menu render and remove the automatic point cloud mode. So now I will have to reshade my point clouds manually in this menu using reshade point clouds or compute point clouds if my geometry has changed. So let's put 0.6 in reflections. Okay. I don't see anything here. This is because by default in the render options, the reflections are disabled because you can actually choose between two different algorithms. So let's put ray tracing. So here I have some sharp reflections. And whenever you have sharp reflections like this, you always have to use ray tracing because point clouds won't give you any good results. Here, for example, if you choose point clouds, you can see that the point clouds don't give good results for sharp reflections. But if you add some blur, for example, let's put reflection blur to 0.3, now the point clouds give you a nice smooth result without any grain, while in ray tracing you would have to increase the samples a lot to have a smooth result like this. And again, this won't have flicking in animation, which is quite interesting. So let's store this image again. Let's also add some background color. So I'm going in menu view, background. I could use a background image if I want. Here I'm just going to use a blue color. Okay, so now I have my blue color. Now let's add some geometric complexity in the scene because this scene already contains a fur generator node that is hidden. So let's search it using the hierarchy view filter. Let's type fur. Okay, here it is. So fur generator nodes allow to create procedural fur over a surface, and it has a lot of procedural parameters to control its shape. So if I use the shading tree in geometric graph mode, I can see that the fur gen node has another geometry as an input, which is the underlying mesh, and it also has an input texture to control the fur density. So if I double click on the fur gen, I can see the geometry that it creates procedurally on the fly. And it's not visible in my rendering because the visible attribute is set to off. So if I press space, I'm going to have here the rendering with the fur. So rendering is being refreshed with the fur geometry, so it's a little bit longer. Okay, so now I can toggle before and after to see what the fur adds in my rendering. I can use the shading tree in material graph mode, and if I select the material, I can see that it is different from the previous ones because this one is specialized for fur. And if I change, for example, the diffuse intensity, I can see that even with fur, you have instantaneous results, so it's really fast. Let's put a value of 0.8 here. Okay, and well, now if I zoom in my image, I can see that anti-aliasing is not good enough now that I have added some thin fur. So I need to change the render settings. But before, what I have to do is to regenerate my point clouds because they don't contain the fur yet, since I choose to generate the point clouds manually. So let's go in menu render, compute point clouds. I'm going to check the shade so that they are shaded too. Let's go. Okay, now to change the anti-aliasing, I need to go in menu rendering here in the render options, and the attribute I want is pixel sampling here. It's set to 3, meaning that you are having 3 times 3 samples per pixel. So let's increase it to 6, for example. So I'm having 36 samples per pixel. Let's change the filter to Lanczos with a filter size of 4. And now I can see the rendering being refreshed. So it's a little bit darker because now the point clouds are seeing the fur, so the fur is darkening a little bit the overall illumination. Okay, so now rendering is done. I can check the fur and see that it looks much better, much smoother now. So I can store this image, and well, I done my rendering with production quality render settings. I have 3 lights with soft shadows, I have glossy reflections, I have global illumination, the geometry is in subdivision surface, I have some fur. So it was quite fast. But let's imagine that now, for artistic reasons, I would want this region below the character to be a little bit more saturated and a little bit more dark. There is no physical reason about it, but I just want it like that. So, well, usually doing that in 3D is a little bit complicated, so the typical workflow is to do it in 2D by exporting several layers. So of course you can do that in Relight. You can render several images at a time using the AOVs, but there is actually a better way to do it using 3D compositing in Relight. So let's see how to do that. I'm going to change the shading tree mode to render options graph. So I'm seeing everything connected to the render options. So I have the camera, and this node, which can be seen as a pass, is called Vis group in Relight. So I'm going to right click and create a color correct node. So there are several color correct nodes with lookup tables or hue saturation value. So here I'm going to create a HSV node. Let's put saturation at 2. And now if I connect it to the color correct, I can see my entire rendering color corrected, more saturated. So it's not very interesting because I just want that in a specific region. So what I'm going to do is I'm going to create a 3D mask. So here, and I'm going to create a sphere mask. So now if I check in the 3D view, I can see what it is. It has a fall off, and if I press H in the render view, I can see its effect. So now if I connect it to the weight of the color correct, I can see that now the color correction is only applied in this region, and I can move it so that I can change the region where it is applied. So I am going to put it just below the character. So let's put the saturation at 2, value at 0.8. Actually, I can even change the fall-off by right-clicking here in the fall-off ramp and by editing the curve. So I'm selecting the curve, I'm pressing on the smooth button, and I'm changing the tangents here so that I can see that, well, I have an instantaneous refresh and I'm doing 3D compositing here in my scene. And these color correct nodes are very interesting because here we apply them on the whole rendering, but you can also apply them on specific materials or just for the reflections, for example, or for input textures or at the output of a light illumination. So it gives you a deep control on your rendering. So okay, this is good. So now I'm going to prepare the batch rendering. So I'm going to uncheck the automatic refresh. I'm going to go in the output section of the render options, put the last frame to 5, just rendering 5 frames. And now let's go in menu render and render sequence. So now my sequence is being rendered. Okay, back here. So now rendering is finished, and an image viewer appears, so I can see my 6 frames here. And as promised, well, you don't have any flicking, neither in the fur nor in the GI or in the glossy reflections.